guys, you're welcome to another episode of my indices explanation. So we want to talk about decimal power and basis under indices. So we want to see how we can be able to easily solve these problems with the use of knowledge of indices, because there are various dimensions of indices that is being explained and you need to understand. So let's see how to solve this very one. I have solution here, but before that, let me give you a brief summary of what this is all about. Sometimes they might express a particular given value in decimal and they want you to leave it and evaluate that value, and you have to use indices, the knowledge of indices to solve it, because it usually is to have power. So you need the knowledge of indices to solve it. So what do you do first? Make sure you express every decimal in fraction so that you can be able to understand what to do next. So that is, express every number in fraction. You don't give it any indices, decimal power and base to solve. I get me with powers, and it's in decimal. So what do you do? Express it with in fraction. So here it is. Expressing the fraction will give you 8 all over 1000. So we have this. So the first thing, if you want to express any number in decimal, just write everything without the point. It will be 0008, which is still 8. Because if you press 0008 without this point, it's giving you 8 in calculator. Then all over, take this point as 1, then the remaining digit as 0. So we have that. So everything raised to the power of 1 all over 3. So what does this give us now? This raised to the power 1 over 3, as we discussed in our previous video in the law of indices. This is the same as the third root of 8 and 1000. So the third root of 8 and 1000, you can further write it as this, because this one might confuse students. This, whenever this third root is outside, it means it's for both of them. You can write it either big like this, or you can write it small and break it for each of them. So we have this and this, so for 1000 and for what? 8. So what is the third root of what? 8? You discover that the number that you multiply by it is going to 3 places to give you 8, and that's 2. Now I ask us to be conversant with those words, values and their power. Then here we have 10. 10 multiplied into 3 places give us 1000. So when you divide this, you give 0.2. So if you understand the concept of dividing converting any fraction to decimal that has a base of 10 or multiple of 10, it has a base that is the denominator of multiple of 10. You just know that you don't move this value one step and put a point. That's for that. Then we have b. How do we solve this b? We have 0.25 raised to the power of minus 2, which is an inverse. Minus raised to the power minus is the inverse. But first we convert it to fraction. We have 25 all over 100. Then raised to the power minus 2. So this one is very easy. Now what do we do here? You can either square it and apply your inverse, which is 1 over, or why not first bring it down to the lowest end. 25 here is 1, and 25 in 100 is what? 4. So furthermore we have 1 all over 4 raised to the power minus 2. Raised to the power minus 2. So what does that give us now? I've told us earlier on that whenever you have minus, it's inverse. And inverse simply means, according to the law we did in the previous, it means opposite, breaking it back. I get it, reciprocating it. You have 1 all over 4. What if you now bring it? You now bring it, turn it to what? 4 over 1, which is still 4. Or if you want to just express it in a way that you understand it using the ideology of indices, you can put here and link it down to power law. This one, 1 over 4 is 1 raised to the power minus 4 raised to the power minus 1 raised to the power minus 2. So what will it now be? According to what Euler's power law, what do you have? You have 4, then minus 1 times, because it will multiply, minus 2. So what will it now give you? To give you finally 4 raised to the power minus plus 2, which is what? 16. So that is it. But if you want to do it by the normal way, since this is the inverse, just bring it and it will turn to what? 4 over what? 1. Then raise it to the power of what? 2. It's still what? 16 over 1, which is 16. So anyhow you just do it, you just understand the principle. If you are following the right principle, it will always lead you to the right result. So either you link it, if you link it to this place, it gives you the right result. If you still do it the normal way, it will still give you the right result. I can even decide here to do, this is 1 all over what? 4. And I'm taking the inverse. Some people understand this inverse as anything you have here will be all over 1. And that means all everything you have here will be what? Under 1. That means as the denominator of 1. Or you put all over 1 on the top. That's what they understand this as. Even that's how I understand it before. So you have 1 all over 1 over what? 4. Raised to power what? 2. That's what this thing means. That means 1 will come up. That means it will become a denominator. So if you see it that way, what you have is 1 all over 1 divided by, because this is divide, 1 divided by 1 over 4. So that 1 divided by 1 over 4, I can put it over 1. So for me, it will be 1 over 1 multiplied by 4 according to the reciprocal law in what maths. 4 over 1, which will give you 4 as our final answer. Then the 2 raised to power 2 is still there, which is 16. So anyhow you just do it, you still have the same value. So let's see the next, which is C. And C says 32 into or raised to power 0.2. So this one is now very quite tricky, because the base is not the one that is in decimal now, but the power rather. But it does not change anything, just maintain the principles. What is the principle? Convert any the decimal you see here to fraction. This in fraction will give you 2 all over 1 and the next digit there as 0. So that is 2 raised to the power 2 over 10. And instead of doing this thing like this now, because what this thing means according to our fraction column is that this one will be the root, 10th root, and this one will be the what? Square. So I'll find the 10th root of 32, which does not even exist as a whole number, and raise it to the power of 2. So which will be very difficult. But why not break it down? 2 goes here, 1. 2 goes here, 5. So it will now be 32 raised to power 1 over 5. So it's now looking like what you know, 5, 32. So there's something that you raise to the power of what? Raise to the power of 5 to what give us the 32, and that is what? 2. So what this means is what? The fifth root of 32. And what is that fifth root of 32? We just said it now, which is 2. So you will raise it to the power of 5 to give us what? 32. So that means the fifth root. Fifth root means bring it back. This raised to the power of 5 gives us 32. So fifth root, what will I raise to the power of? I get it. What I raise to the power of 5 will give me what? 32, and that is what? 2. So that is all for that. So you can follow me, subscribe, like, comment, and share for more videos on this and other topics, so that you can be able to grasp the depths. I take time to analyze and explain it step by step. So that is that. We'll see probably more videos on the promised video I said I will drop under what a trick of indices being turned to factorization.